Hello guys, I'm Kumar K, your favorite DSA teacher when it comes to solving hard and thin DSA problems of online assessments of top tech companies like Amazon, Google, etc. And interesting and difficult coding contest, comparative programming problems. Today, we are going to solve a very interesting question, guys. It was asked in Amazon online assessment on 21 December. Just 4 days back, this problem was asked. It's a very nice problem, and many people are giving Amazon online assessment, so it's my responsibility to discuss the solutions so you can understand, guys, what type of questions are coming these days. Also, guys, coming to our introduction and our love for DSA. Previously, I worked at Amazon and Mir.net as software engineer. I was from a tier 4 college, but still I managed to crack those offers off campus, and that's why I guide my students for the same. Also, guys, coming to my love for DSA, I've All India ranked 12 in Google Code Gem 2021 and All India ranked 4 in the recent Facebook Hacker Cup. Now, guys, it's the time to congratulate our favorite student or the top student of this week. So, guys, Harini was trying very, very hard since a long time. She was, it was her dream to crack a FANG offer off campus. So she tried a lot, but she was constantly failing because in the Fang OA and the top tech companies online test, they ask you hard unseen DSA question story based. Their interviews are also very challenging. Then she joined our mentoring, one-to-one mentoring and daily life training program cohort and 850-hour course and the referral support and everything. After 8 to 10 months of hard work, she has cracked off-campus offer from Amazon 4 days back. So congratulations to Arini. It's very nice to see such selections. So there have been many Fang selections, and this is the one which happened pretty recently. Okay, it's the eighth off-campus Fang selection of this month. So guys, if you are one of the people who want to take their DSA skills to the next level, want to prepare for Fang level OA interview, want to prepare for CP, they want full stack development and system design training, one-to-one mentoring by me, off-campus job search training, and the referral support of top 500 companies, and the personal guidance, help, and support. You can check the link in the description for our Christmas offer. Now, guys, going towards the question. This question is very interesting, guys, and I will teach you how you can build up the intuition and logic for new DSA problems, because people keep on doing standard DSA problems and then they keep on facing the issues. But I don't want you to face the issue for long, so your issue should get resolved. So I will be explaining this problem, guys, in a very nice brilliant manner. But not but if you like this video, make sure you like the video and subscribe and comment. Also, guys, you can comment in the YouTube comment section on which company you want the next OA video to be. Now, guys, coming to this video, and this particular question of Amazon OA, what they're asking you is that maximum stability score. The actual source link of the question can be seen here. So, guys, you are given two arrays, array A and array R. You have to choose a subset. You have to choose a subset such that the minimum of A of I of that subset multiplied by the sum of R of I of that subset is maximum possible. Okay. So, guys, you can see that the question looks a little difficult when you read it, right? I will show it to you with some examples. Okay, let's take some examples. For now, it's a good choice to take some examples in front of you people. Okay, so guys, let's quickly go to the examples. Let's say I take 5 year, 10 year, 15 year, 20 year. Okay, so we are taking some nice examples. -5 year and -8 year. Okay. So guys, you can pick up any subset. Let's say this is array A and this is array R. So let's say I say that I am picking the subset. I am picking this element and this element in my subset. So what will be my subset? 5 and 15 I have selected from the first array A. And which are the congruent elements with 5 and 15 in the array R? They are 10 and -8. So guys, from the first set of selected elements, you have to take the minimum. So you have selected 5 and -5, right? It's not -15, it's -5. So what is the minimum of 5 and -5? Minimum is -5. You have to multiply it with the sum of this. What is the sum of 10 and -8, guys? 10 minus 8 is 2. So -5 into 2 is what? -10. So subset means pick up any elements you want from array. Guys, I hope do you you understand the meaning of subset. Subset means pick up any set of elements from array, but you should optimally pick up such a subset which will give the maximum stability score in the end. So let's see how can we demystify this mystery. So guys, you can see that when you select 5 and minus 5 in the subset, the answer is coming as minus 10. Now, guys, just pause for a minute and think, is there any other subset which if you choose so that the answer can become bigger than minus 10? Is there a better answer? If there is a better answer, that is our final answer. That should be our final answer if that is the biggest possible answer. So, now, guys, the best answer is not 5 and minus 5. Nah, 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 nah. The best answer comes up when you select 5 and 15. So now what will happen if you select 5 and 15? What is the minimum of 5 and 15? Minimum of 5 and 15 is 5 multiplied by sum of the selected elements on the R side. 10 plus 20, 30. So what is 5 into 30, guys? 150. So 150 is one of the possible answers bigger than minus 10. So 150 is a better choice. Guys, there is a choice which is even better than 150. Even better than 150 option is there. Do you want to know? What if you select only one element in the subset? You only select one element 5. So the congruent element in R is 10. So if you multiply them, it is 5 into 10, 50. Nah, nah, nah. This is not bigger than 150. The best answer is if you just select this element in your subset. See, guys, in subset, you can select either one element or two element or three element, whatever you want. But you have to find the best possible answer. So and the order also you don't know in which you should select if it's more than one element, right? In one element it's easy, either the first, second, third, or fourth, fifth, sixth, all the way till the end. So now here in this case, if you select the second element, that's the best answer. Why? From array A, 15 will be selected, and from array E, the congruent array R, the congruent element is 20. So guys, what will be 15 multiplied by 20, guys? 15 to the 30, it will be 300. 300 is the best answer to this problem. Okay. So, guys, I hope that I was able to make the understanding of this problem clear to you. Okay, so let's take one more example. So, when it comes to one more example, let's take the example given here itself. Okay, given two arrays A and R, you have to pick a subset of elements so that this score is maximized. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, guys, I'm taking it in front of you. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, no, no. It's not 1, 2, 3, 4, 5. What it is? Let's see what it actually is. Such a nice, interesting problem, right? So it is 1, 2, 4, 3, 5. So, guys, array A is 1, 2, 4, 3, 5. What is array R? The congruent array. It's 5 minus 1, 10 minus 5, 15. 5 minus 1, 10 minus 5, 15. So, guys, I hope you can feel this array. Yeah, I am sure Google Meet, naughty Google Meet. Anyways, going back to the question, Ram Ram. So, guys, the most important thing is you. I hope you can feel both the arrays. Array R is always attached to array A. Okay, you can use 2D array also if you want. So now, how do we demystify and solve this hard unseen DSA problem? So, guys, what subset if you choose, you will get the best answer. Someone might say, sir, what if I choose 4 and 3. So what will be the answer if you choose 4 and 3 in your subset? 4 here, 3 here, 10 here, minus 5 here. Guys, what is the minimum value in 3 and 4? It's 3. And what is the, for the R elements, you have to take the sum of the subset. So 10 minus 5, 5. So 3 into 5 is 15. So guys, 15 is the 15 the best answer. You can pause the video for a minute and think about it. Okay. So guys, is 15 the best answer? No, there is a better answer possible. The better answer is you should select 4 and 5. 4 and 5 gives the best answer, guys. Now let's see if that is true. 4 and 5, and the congruent elements are 10 and 15. So guys, which is the minimum of 4 and 5? 4. And what is the sum of 10 and 15? 25. So 4 multiplied by 25, 100. 100 is the best answer possible. If you take only 5 and 15, 15 into 5 is what? 75. So 75 is not going to beat 100. So guys, the best answer is when you pick up the subset 4 comma 5. When you pick up 4 comma 5, obviously the congruent element sum you have to do and multiply with the minimum of the selected subset. That's it. But now guys, we cannot do brute force here, right? What is the basic brute force? Basic brute force is of 2 raised to n time complexity. You can try to generate all the subsets of A. Then for each subset, try to calculate the sum of the congruent subset in R and the minimum value of the subset in A and multiply and see the value and take the max of all of them. But that will take 2 raised to n into n time. So, 2 raised to n for generating all the subsets and n time for going through the subset. In worst case, the subset size can be as large as n, right? So 2 raised to n into n. Though in average, it will be 2 raised to n into n by 2, something like that. But anyways, let's ignore that. So, yeah. So guys, you can see this is such a nice, interesting problem. Now, how will you solve this hard unseen DSA problem? What thought process can you do? Think about it. So guys, we are trying to take the sum of the array. We don't know what subset sum to take, what to do. But guys, one thing we can do. What is that one thing? Think about it. Think about it. That one thing is that you can fix the minimum element. What if I sort the array A? What if I sort the array A? Now this will look like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now guys, 1 should be attached with 5, so 5 is here. 2 is attached with minus 1, so minus 1 is here. 3 is attached with minus 5, so minus 5 is here. So I hope you understand that while sorting, the order of R will also get changed because R is directly connected to A. 4 is joined with 10 and 5 is joined with 15. So guys, array A has also been sorted, array R has also been sorted, right? So guys, now you can feel that the array A has also been sorted and array R has also been sorted. Now what will you do? Guys, you can fix the minimum element. What would be the best answer to your question? What would be the best answer to your question if this last element was your minimum element? If minimum element was 5. In your equation, whatever subset you are trying to choose na, from array A, what if 5 was the minimum element? See, what you have to do, na? You have to take the minimum element from array A and multiply it with the same selected elements of sum of the elements from array R. Ignore the sum. You can fix the minimum, right? So guys, if 5 is the minimum element, then which element can you put in the subset A? You can only put 5. You cannot put 4 comma 5. Why? Because if you put 4 comma 5, the minimum will become 4. You want the minimum to be 5 only. You're trying to fix the minimum. So guys, do you understand what trick I'm trying to do? I'm saying that whatever final formula you want to maximize, what can be the minimum values? Either it can be the last element of the sorted array, or the second last element might be the minimum of the selected subset, or the third last element of the sorted array might be minimum, or all the way up to first element of the sorted array might be the minimum if you are selecting all the elements of array, right? सो गाइस, अगर तुम मिनिमम को फिक्स करने का ट्राई करते हो, लेट्स से कि भाई तुमने फिक्स कर लिया कि मिनिमम तो 5 ही होना चाहिए, देन यू कैन ओनली सिलेक्ट वन एलिमेंट इन योर सबसेट विच इज 5. इफ यू सिलेक्ट 5, what will be the sum? Only one element here you can select in congruency, which is 15. So 5 into 15, 75 is one of the possibilities. Okay, okay, okay. Now let's try another possibility, guys. One possibility has been checked. What is another possibilities? Let's say I say that minimum This time try to find the best answer such that minimum is equal to 4. Minimum is the second last element of the sorted array. So guys, अगर आपको अलाउ कर दिया गया है कि बेस्ट आंसर निकालो सच दैट जो भी आप एरे ए का सबसेट ले रहे हो उसका मिनिमम 4 आना चाहिए, इसका मतलब क्या हुआ? इसका मतलब आप 4 या 4 से बड़े नंबर्स ही ले सकते हो. मींस यू कैन ओनली सिलेक्ट द नंबर्स ऑन द राइट हैंड साइड ऑफ 4 इंक्लूडिंग 4. एंड सेम गोज फॉर आर. So the problem has been solved, guys. How? See, your minimum should be 4, right? It means you can select this whole part. If you select this whole part, na, the minimum will come as 4 only, and 4 must be included forcefully. So minimum 4 means you can take in 4, you can take in 5, and things like that. And in the congruency, there will be 10 and 15. So what will be the minimum of 4 comma 5, guys? It will be 4, and here you will be multiplying with 10 comma 15, which is 25. So 100 is one of the possibilities. Guys, what is the next possibility? The next possibility is, what if I want to make 3 as the minimum? Now what will I do? I want to make 3 as the minimum. Now what to do? Means I can select any elements from 3 on the right hand side. So I have to select a subset from A, and the same congruent subset will get selected in R. I want to make sure that the minimum is 3. So obviously I have to put 3 here. And here I can put any numbers. So guys, I hope you understand that if you want to make sure that the minimum element of the subset of A is 3, you have to put 3 in it first of all. Now you can put any elements bigger than 3 in it. So guys, which elements will you put bigger than 3? You can put 4 or 5, or you can put both of them, right? The minimum will be what? 3. And this will be multiplied with this sum. And guys, you have to maximize this sum. तो तुम ही दिमाग लगाओ ना. 3 has been selected means minus 5 is coming in the sum for sure. How can you increase this sum? Basically, your final answer is going to be 3 multiplied by minus 5 plus something. How can you make this value bigger? Guys, now comes the greedy concept. See, 3 into something, you have to maximize this value. 3 is a positive number. 3 is a positive number. So if a positive number is multiplied with positive number, then only the product will increase, right? So guys, here minus 5 plus a very big positive number you have to add. So you should add 10 and 15. So I will add a 10 here. I will add a 15 here. This will make this right hand side also very big positive number, and 3 is fixed. So 3 into big positive number will be a big value. So that will also be one of the possibilities. Now guys, let's discuss the next thing. Okay, now guys, this time I want you to solve the problem. I want you to solve the problem. Another possibility, guys, I want to choose a subset A such that the minimum comes as 2. So guys, you have to choose a subset A and you have to choose a subset R congruently. So in A, minimum should be 2. It means 2 will come for sure. Other elements we don't know, but 2 will come for sure. And here, the partner of 2, like the bonding of 2 is with minus 1. Minus 1 will come sure. About others we don't know. So 2 will come sure, and here minus 1 will come sure. Okay. 2 will come there sure, and minus 1 will come there sure. But here you can, now which elements you are allowed to select? You can select any elements from 3, 4, 5 to maximize your answer. So guys, if your minimum is fixed at 2, you can select now any elements greater than 2, because anyways the minimum will be 2. Now you only focus on maximizing the R sum, because as the R sum increases of the R subset, the final product will be maximized. Such a brilliant greedy problem this is. Greedy algorithms getting used here. Guys, make sure you like and subscribe our channel and show some love. So guys, we can select anything from 3, 4, 5. Does not matter. The minimum of all of them will be 2 in only. Now you have to multiply this with the R sum. So guys, minus 1 has already been selected. Tell me which element should you select from here so that the sum increases. Minus 1. I can select everything. Minus 5, 10, 15. Should I select minus 5? No, it's decreasing the sum. You should only select 10 and 15. So if 2 is fixed, you should select 2, 4 and 5 in the subset. Minimum will be 2 and here the sum will be minus 1, 10 and 15. So the final answer will be 2 into minus 1 plus 10 plus 15 if 2 is fixed as the minimum. Similarly, guys, you can solve the problem is 1 if 1 is fixed as the minimum. If 1 is fixed as the minimum, guys, you know, guys, that here 1 will be there for sure. The other elements does not matter, the minimum will come as 1. In the R, 5 will be there for sure because 1 has to be included, then 5 will also get included. Which other elements will you include, guys, apart from 5 to increase the right hand side sum? You will not use minus 1, you will not use minus 5, you will use 10 and 15 because they are positive numbers. So 1 into 5 plus 10 plus 15, which is what, guys? 1 into 30. And 30 is coming as the answer. So, guys, we have solved the problem actually, okay? The problem has been solved by greedy algorithm. Hopefully, guys, you enjoyed the solution to this problem. Now, let's go towards some of the details. So, guys, lovely people, best subset obviously in this case is 4, 5, 10, 15 bonding 4 into 10 plus 500. But observation is what will happen if we sort the array A and try to fix the minimum element. When you sort the array A, elements of R also change with A index wise. You know that. First, we will try to find the best answer if A of n was the main element. Then, guys, you will try to find the best answer if A of n minus 1 was the main element. Guys, you will do this again and again, then you till you try to find the best answer if A of 1 was the minimum element, and you take maximum of all those possibilities. Maximum of all those possibilities is the final answer. Now, guys, the nice thing is that even after doing all this, now your program will still fail on few test cases. So let me show you. This is the brilliancy of greedy algorithms, that somewhere, sometimes, if you don't handle the corner case or if your logic is wrong, it can fail. So let's see where it can fail. So, guys, the thing is that the array elements can be negative as well. Okay, I told you that the array elements can be from 1 to 10 raised to 5 can be the size of the array, and AI and RI can be minus 10 raised to 9 to plus 10 raised to 9. So let's see what happens when that happens. So when the array elements get negative. So uh, basically what happens when the A array can have negative elements, okay, because the minimum element is fixed. So if the left hand side is also minimum element, right hand, if the left hand side of the product is negative, right hand side also should be negative, because negative into negative will give a positive final value. That's why. So in some of the intelligent students must have understood, like there are many these type of greedy problems, detailed solutions, algorithms, in building conceptual logics and all in our 850-hour course of greedy. If you check it out, now the course has become 1,000+ hour long actually. So now, guys, yeah, you can check the link in the description if you want it for the Christmas offer. Special discount is there. Now, guys, listen up. Ram ram. So uh offer is almost there now, guys. Let's take some nice example which can make the things interesting for you. So I will take the example directly from here. Minus 1, 2, 3, 4, 5. Minus 1, 2, 3, 4, 5. Okay. And the next thing, I have sorted the array, okay, for ease of convenience. Ease of convenience, very important. Then, guys, the next thing is 5 minus 100 minus 50, 10, 15. 5 minus 100, 5 minus 100 minus 15, 10 and 15. So, guys, if I ask you the question, hey, what will be the answer? Best answer if your minimum element is fixed at 4. You know that there will be two subsets. One will be from A and one will be from R, right? So here 4 will come for sure. Other elements coming here don't matter because the minimum element will be 4 only. But yeah, Here the 10 will come for sure. Other elements do matter here because you have to increase this sum because this will get multiplied by 4. So here you will use 10 is there, but another number you will use 15 also. Okay. And here if you include 5 does not matter, the minimum of that will be 4 only. So 4 into 10 plus 15 which is 100. Like it's 4 into 25 which is 100. Okay. So guys, you know how to solve the problem when minimum is equal to 4, right? Whenever you are at a current number, na, you know that this is the minimum, right? You know you have to fix this number also. Now, here you will take the sum of all positive numbers. Sum of all positive numbers in the suffix. If you add those numbers with this number, the R subset value will increase a lot. And then the 4 into R will be maximum because R is very big positive number. So, I hope you have this much logic ready with you guys. I hope you understand that when once you, let's say you have sorted the array and the R guys have also changed their positions according to that. Now if you fix a minimum element, let's say A of I is the minimum element, I'm fixing it off. Find the best answer if A of I is the minimum element in the subset selected. Answer will be A of I into Y. Y will surely include R of I. Now with R of I, what should I include to maximize Y? With R of I should add the large all the positive numbers which are available in R array from range I plus 1 to n. Okay, so this much logic, I hope it's clear to you people. Okay, so let find answer if I is the minimum element for A subset. So answer will be A of I into R of I plus Y. Y is random, you can select, but what should be the optimal Y? Think about it. What will be the optimal Y? So optimal Y will be sum of all positive numbers. You can easily maintain that from index I plus 1 to n. Done. So if you add all the positive numbers, R of I plus positive numbers will be a big number, and if you multiply the big number with positive A of I, the answer will be as maximum as possible. We assume here that A of I is positive. A of I is also positive. It means you're you're trying your best to make R of I plus Y also positive. Okay, by taking Y as sum of all the positive numbers. If R of I plus Y gets negative, it's not a good situation, guys, because positive into negative will be negative, and negative is not the maximum number, right? So this much is clear. But now I want to show you a brilliant case which makes this problem very, very interesting. So let's go there. Now, life is very interesting. You should always be very, very happy. God gives this chance to us only once. Now, uh, what if you try to fix minus 1 as your element? Now, guys, this time your minimum element is negative. So, you can take minus 1 and any other elements here. And here 5 will come for sure. You know that in the end, minus 1 here will be the final answer on the left hand side and multiplied by the product. Now, you guys might try to think, sir, this second value should be positive, right? As positive as possible. So, if you put a 5 here, and then ignore the negative numbers, only take the positive numbers 10 and 15. What is going to happen? Minus 1 multiplied by 30. 5 10, 5 10 15 20 30. Minus 30 is coming as the answer. Oh ho ho ho. Guys, can you see the answer ruined? We wanted a big positive number as the answer, maximize the answer, but we are ending up with a negative number. Why? Because our minimum element is minus 1. So with which number if I multiply minus 1 so that the answer will get big? I need to multiply minus 1 with a negative number. So maximum negative sum subset you need this time. This time, you don't need positive sum numbers. No, 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 no. To increase the answer, if this is negative, obviously 5 will come here. But try to take all the sum of negative numbers now. 5 minus 100 minus 50. Now, what will happen? Minus 1 into what is 5 minus 100 minus 50? It is minus 145. Minus 1 into minus 145 is plus 145. So hopefully you guys enjoyed the logic. So guys, this is the logic of this problem. Time complexity will be n log n plus n, right? Because the it will take some time for you to sort the array, right? You have to sort the array of pairs because you have to keep the r also connected. So guys, n log n, okay, 2 n log n or whatever, but n log n basically. And plus n, you will again have to travel the array, right? And let's check the C++ code out. Like if you try to include the space of sorting, it will take more time, but let's assume that we are not counting the space of sorting here. So it will take just o of n one, size space, etc. Okay. So guys, in the C++ code, you can see that I took the input of array a, array r, and then guys, I'm putting that in a vector of pair a comma r. I'm sorting g. Okay. Then guys, I'm going from the last element, trying to fix that element. So what if I equal to n minus 1 was my minimum element of a? So obviously the minimum is fixed, right? It is p multiplied by minimum is g of I dot first multiplied by the congruent element g of I dot second plus the g phi, the sum of all positive values from I plus 1 to n. So you can write it here also if you want. G phi is nothing but what? Sum of all positive in range I plus 1 till n. And similarly, guys, G2 is nothing but sum of all negative numbers in I plus 1 to n. So you get the answer by multiplying, right? R1. You will take maximum of all possibilities. So again and again, whenever you generate the answer, guys, you will keep on taking maximum of all the possibilities, okay? So hopefully you are liking and enjoying this problem a lot. So guys, this is done. And guys, when it is negative, what will you do? This time the current number with the sum of all negative numbers in I plus 1 to n. And multiply with this with p, and p is also negative this time, right? No, g of I dot first is also negative. So negative into negative will be positive as much as we can try. And guys, as we go backwards, we are always traveling from back till like this. So as we go from back till here, now, whenever you see a positive number, you add it to g5. You see a negative number, add it to g2. So you always have the sum of the suffix positives and suffix negative. Zero does not affect anything. So, don't need to worry about that. So guys, that's it, and the problem has been solved. We can check the Java code also, which is very, very interesting. Same concept, guys, same concept. Nothing is different. You can check it out. And guys, Python code, very popular these days. Python is same concept, guys. You take in the things, you sort them, and then you travel from the end till the start. If it's positive, do this. If this negative, do this. And guys, 50 LP Amazon OA problem has been solved. So hope you guys enjoyed this problem. Take care. Merry Christmas, and love you all. Take care. Good night. Merry Christmas and Ram Ram. God is the most important. Ram Ram.